Alright, so in this question, we are given a point P, and we're told that that point joins the line A to B, and we're asked to show that the point's coordinates x, y satisfies the following relation, which is y equals 3x minus 9. In these kind of questions, the best way is to start diagrammatically. To show the points A and B initially, let this point be A with the coordinates 3, 0, and let this point be B with the coordinates 5, 6. Now, we know that the point P lies on the line connecting A and B. So the line has to be this. This is our line that we should be concerned about. But the point P can lie here, could also lie there, or could lie there. So you basically have divided the line in three regions where the point can lie. It could lie in the middle of A and B, it could lie away from B, it could also lie away from A. But in all three cases, if the point P lies here, there, or even there, the gradient of AP or PB or AB are the same because they lie on the same line. As we've shown before, that the line has a constant gradient. Therefore, the slope or the gradient of the line segment AP should be equal to the slope or the gradient of PB, should also be equal to the slope of the gradient of AB, no matter where the point P lies. So let us assume that the point lies, say, here, in the middle of A and B, but more generally, the point can lie anywhere. Let us assume that in this particular scenario, it lies here. In those cases, let us write the slope of AP, as we know that the gradient has the formula y2 minus y1 upon x2 minus x1, which is also known as the slope, as what I've been referring to it so far. We can use this formula to find the gradients or the slopes for this, this, and this. So for AP, slope of AP turns out to be, well, difference in the y coordinates, y minus 0, divided by x minus 3. The slope of the segment PB turns out to be 6 minus y divided by 5 minus x. The slope of AB turns out to be independent of the coordinate of P, and that turns out to be 6 minus 0 divided by 5 minus 3 in that particular order. That turns out to be 6 over 2, which is nothing but 3. So we have a following set of equation: y upon x minus 3 equals 6 minus y upon 5 minus x equals 3. Now we can choose any two of these sides about the equality and show that this relation is satisfied. Let us take a simpler case of choosing this being equal to a constant 3. In those cases, what we have is the following relation: y upon x minus 3 equals 3. What we can do is we can multiply both the sides by x minus 3, and that gives us y equals 3 times x minus 3 times 3, which is 3x minus 9. So we know that wherever the point lies, be it here, there, or even there, it always satisfies the following relation, which is quite strange. Or maybe it isn't. In any case, this gives us a segue into what we call an equation of line. So far, what we have done is we have basically equated the slope of every point that lies on this line to the slope of the 2 points, or the line segment, which was generated by the two fixed points, A and B. So no matter where the point lies, it always has the same slope with respect to either of the two initiating points, A or B. And we use that equation to solve for x and y, the generalized coordinates for the point P. And what we ended up with was this relation of y equals 3x minus 9. Now let us see if this relation is satisfied by A and B. So for A, we have, well, y is 0, and x is 3 times 3 minus 9, which is 0. So LHS equals RHS, and hence A satisfies this relation. So A does satisfy this relation. What about B? For B, the left-hand side turns out to be, well, 6, and the right-hand side turns out to be 3 times 5 minus 9, which is 15 minus 9, which is 6. So even in the case of B, the LHS equals RHS. So P could very well have been A or B, it didn't matter, or could in fact be any generalized point lying on the line which is generated by A and B. What we ended up with finally was this relation, and we have now shown that every point lying on the line satisfies this linear relation of y equals 3x minus 9, which is generated by these 2 points.